You received your box and you unpacked everything. You have on your desk power supply, needles, rail. The laser module is optional. Then limit switches, small stepper motor supports, the main stylus and other things. You have also a set of tools that allows you to assemble the PSE-22 that, by the way, is pre-assembled. The gamepad is provided. The blocks X and Y come already assembled. The stepper motors and the belts are already installed. The centering nuts are already set properly. The control boards are already in position and configured. For the USB version, we have two USB cable extensions, relay with protection circuit, power supply for the electro valve, and pedal switch. Obviously, the new pump is provided, as well as the two microscopes. For the AV version, you will receive the 9-inch monitor with two input channels. The two AV microscopes come with two power supplies. Green mat and component rack are optional. The tools consist in two wrenches 5.5 to 7 and 8 to 10 mm. Then we have three hex keys, 2, 2.5 and 3 mm. The 2 mm is used only for the laser module. We take the bars and we connect them together using the T-nuts. Use the gamepad box as support. Lay the stepper motor on it. Then you may want to check if the bars are just connected without having a small vertical step. If so, lose a little and fix, just as I'm doing here. Then it is the moment of the X-axis. We will calibrate it later. Screw in the first screw just a little, using your hand. Then proceed to the opposite side and put on the other two screws without tightening. Pay attention to the cables. Put on the remaining screw, but do not tight. Let the x-axis to pitch forward and backward with a little of resistance. We need to set the perpendicularity to the plane. I use this tool, but also a small triangle ruler square will do it. You move, pitching the X-bar till you reach the perpendicularity. Once satisfied, you start to tie the screw, checking again that the X-axis didn't rotate a few degrees. Now it's the moment to check if the stylus is perpendicular in relation to the y-axis. As you can see, it is far out. I did it on purpose. In reality, you should fix by a small amount, because I use this kind of system. When I assemble the bracket, it lays down on two nails that are inserted in two holes made on a line parallel to the x-axis bar. If you need to fix a little the perpendicularity, insert back the two nails, then release a little the bolts and the nuts using the wrench number 7 and the hex key number 3. Then remove only the nail to the side you have to lower a little. Now we mount the Z-rail. You have a self-locking screw and a bolt nut. Start with the self-locking screw. It goes in the lower hole. Don't tighten too much. The rail needs to be adjusted. It must be parallel to the stylus. Remove the higher piece of tape and put it in the lowest possible position on the rail. Then remove the other piece of tape, so you can check the perpendicularity of the rail in relation to the X block. When you do it, pay attention. Sometimes the block has a small step created by the CNC. In this case, try to go a little diagonally. The lower gear should be able to rotate freely. We need to mount the support for the stepper motor that controls the rotation. The holes for the bolts are big enough to allow you to set the center of the hole of the support exactly where the center of the linear bearing hole is. While you are tightening, sometimes you stop and you check. Be sure that the stylus is not touching the side of the support hole. The two corrugated pipes contain all the necessary wires. The connectors and plugs are all marked in some way. The pipe that has got the connector for the power supply goes to the Arduino shield. Insert the stylus. Grab the smaller belt. While you tie the screws, you need to put the belt in tension. Do not exaggerate with the tension. Support for the Z-axis motor. Same for this belt. We start with the Arduino shield. The plugs could be white or black, however they are all marked. The small dot on the side means that that side goes up. The connectors on the boards are marked too. The Z connector on the Arduino in reality controls the rotation of the stylus. The Z-axis movement is controlled by another board on the opposite side. The connector marked with the A controls the second Y stepper motor. So we connect this short cable to the A connector and then to the stepper motor. The single DuPont connector will carry the PWM signal for the laser. In our firmware, the PWM pin is connected to the Z+ on the shield. So that is our target. The black row is just all grounds. To control the Z movement, I use the digital outputs, cooler enabled and spindle direction. This combination of two bits is sent to the opposite board. What you see under the magnifier is just that connector. It is marked cool. The other connector carries just only two ground pins. You can connect it no matter where in the left row. This female plug will carry the main power. Now is the moment to connect it. Red is plus and black is minus. Firm the female plug with a nylon zip tie, like I'm doing now. You have also 4 small radiators for the A4988. I personally don't use them. If you want to use them, pay attention to the way you stick them on the board. If the radiator touches the pin, you will have a shortcut and you will fry the small board. The board that controls the Z movement is based on an Arduino Nano or compatible. The power plug is the only one with 2 pins, so no need to mark it. Then we connect the stepper motor. Close to this connector we can read relay. So we go to the relay box and we get the plug. It should be marked with NR. These 2 connectors are marked with 1 or 2 dots. Find the relative plugs. We connect the X stepper motor to its wire. The other plugs here are marked with U for upper limit switch, D for lower limit switch, and the last is marked with an L for laser. Now we will mount the 2 limit switches. If necessary to move the stylus up or down, grab the belt from these 2 sides and pull in opposite directions. Remove the remaining piece of black tape. The lower limit switch is firmed by 2 small nuts and bolts. in the upper side of the X block. The connector is here. This switch is activated by the blue plastic cuboid in the belt, so it should stay under it. You can set the right position, moving the switch up, down, left and right. The plug is marked with a D, down. Upper limit switch. Then connect the plug marked with the U. The block comes with one microscope support already installed. You need to install the second one. We will set the right position of the two microscopes in the next video. We install the rotating joint. When using the wrench, pay attention to not stress the belt, tight just a little. One side of the black tube is marked in white. It signs the amount of tube that needs to go inside the joint. Now we need to pull up the blue ring till it snaps. In this way the black pipe will be held firmly. It is quite hard and once I've broken my nail, so now I use a small plier. Pay attention to not break the limit switches or the support. Maybe you could insert the pipe in the joint before to install it. Then we put on the two microscopes. We firm the microscope's cables to the corrugated pipes. Then we plug to the main power the pedal plug and the pump's power supply. We test the pump. We test the pedal. Holding the two electro valves on your hand, you will feel when they get activated pressing the pedal. Then we connect the electro valves to the transparent pipes and to the black pipe, like in the picture. The black pipe is a little hard, so we need to stress it with a Phillips screwdriver. Now it's easy. When you take the needles, don't pull them from the tip. There is the risk of bending them, but try to take them from the base. Maybe you could use a small tool. The needles are screwed to the adapter. If for some reason you need to inspect the adapter, screw the adapter to the stylus. When you tighten it, hold the stylus, otherwise you will stress the belt. And the last is the needle. Also here, just tight a little. You can see how the belt is stressed. Okay, we have done. It was not too hard. Now go to the next video, how to use the PSE-22.